All right, let's talk about energy, but not the energy in your headlines. We're going bigger. We're talking about the energy that powers our entire planet. We're going to put some absolutely massive numbers into perspective and see exactly where we, as a civilization, fit into the grand scheme of things. Let's dive right in. Think of it this way. Earth has an energy budget. A certain amount comes in, a certain amount gets used. The huge question we're going to tackle is pretty simple. Are we living on our planet's daily income, or are we just burning through a one-time inheritance? Okay, so before we even get to us humans, let's just look at the planet itself. What are the massive natural forces that keep this whole place running? The scale here is, well, it's kind of hard to wrap your head around, but getting a handle on it is totally key to understanding everything else. So, what do you think is the biggest player in this planetary energy game? Is it the heat that's, bubbling up from the Earth's core? The pull of the moon on the tides? Or is it something else entirely? The answer is, well, it's pretty staggering. 173,000 terawatts. Get this, that's the amount of power the sun hits our planet with every single second. A terawatt is a trillion watts. It's a number so big it's almost meaningless. To put that in perspective, it's over 8,000 times all the power humanity uses, combined. And it just shows up every day, for free. And look, this isn't just about getting a nice tan at the beach. This solar energy is the engine for the entire planet. It's what drives our climate, our weather patterns, our ocean currents. And, of course, through photosynthesis, it's the very foundation for basically all life on Earth. This chart right here just says it all. See that gigantic bar on the left? Yeah, that's the sun. Now, try to find the other two. You can barely even see them. Geothermal heat from the planet's core? That's just 47 terawatts. Tidal energy? A tiny 3 terawatts. I mean, they're powerful forces for sure, but they are not even in the same league as the sun. It's not even close. So we've established we're living on a planet that is just drenched in this constant, almost limitless flow of energy from the sun. So now let's bring people into the picture. How have we figured out how to use energy, and how did our appetite for it get so huge? For most of human history, our energy use was pretty basic, right? We burned wood, we used animals for muscle. But then, a couple hundred years ago, everything changed. The Industrial Revolution basically gave us the key to a giant underground treasure chest of energy, coal. That lit the fuse, and then in the 20th century, with oil and natural gas, our energy use just exploded. And that brings us to right now. All of it. Our lights, our computers, our cars, every factory, the entire engine of global civilization runs on about 20 terawatts of power, continuously. Remember that number, 20 terawatts. That's us. And here is the absolute kicker. Where do we get that power? Well, as this chart shows, a whopping 80% of that 20 terawatts comes from burning fossil fuels. That's right. Our entire modern world is built on a foundation of coal, oil, and natural gas. And that has some really big consequences. And this is where we get to the real heart of the matter. The problem isn't necessarily how much energy we use. The real problem is where we get it from. There is a fundamental, critical mismatch between the planet's energy system and ours. I mean, let's just do the math again real quick. We use 20 terawatts. The sun delivers 173,000 terawatts. That means our total global energy consumption is less than half of 1% of the free solar energy arriving every day. So what's the big deal? If there's so much energy just floating around, why is this a problem at all? This table right here lays it out perfectly. The Earth's natural system, it runs on its daily income, the sunlight that shows up every single day. It's balanced, it's sustainable. Our system, the human system, we're running on an inheritance. Fossil fuels are literally ancient sunlight, captured by plants and buried for millions of years. And we're burning through that entire geological savings account in just a couple of centuries. This quote just nails it. We found a planetary bank account, and we are draining it like there's no tomorrow. And the problem is, when we burn these fuels, we're not just getting the energy. We're releasing all that ancient, trapped carbon back into the atmosphere, and that's what's throwing the whole climate system out of whack. Okay, so that is the problem. A pretty huge one. So what's the solution? How do we fix this mismatch and get our energy system back in sync with the planet's? Well, it's one of the biggest challenges humanity has ever faced, and it's called the energy transition. It really boils down to these four big things. First, we have to go all in on renewables, solar and wind, to start tapping into that daily energy income. Second, we've got to figure out better ways to store that energy for, when it's cloudy or the wind stops blowing. Third, we have to get way, way smarter about how we use energy and just stop wasting so much of it. And finally, number 4, we have to completely modernize our electrical grids to handle all these new sources. At the end of the day, when you strip away all the complexity, it's just this simple. We have to stop living off our planet's one-time savings and learn how to live on its daily income. That is the entire game. So the final question is really this. We know the energy is there. There's more of it than we could ever possibly need hitting the planet every day. The challenge is making the switch. Can we build the right technology, find the political will, and, frankly, change our own habits to power our world with its daily income instead of its ancient inheritance? The answer to that question is going to define the future